All right, I think this problem is on week 9 homework. It's gonna have the label of 7.2 0.24 T. I think this may be one of like the test bank problem, but let's go over this together. A study investigating the relationship between age and annual medical expenses randomly sample 100 individuals in a city. So sample size is 100. I'm gonna write that down on a piece of paper. Because in 7.2 you worked with sampling distribution of sample means, and that sample size n is going to be very useful to tell the standard deviation. So I wrote down n equals 100. It is hoped that the sample will have a similar mean age as the entire population. We always want that, right? Complete part A and B below. A. The standard deviation of the ages of all individuals in city is sigma equals 16. Now, what they just gave us is the standard deviation of the population because they said standard deviation of the ages of all individuals in the city. Everybody in the city. So that's population. So the population standard deviation is 16. And we know that's true. Well, we know by just looking at the symbol, that sigma, that little lowercase sigma, that's the symbol for standard deviation of the population. Let's keep reading. They want you to find the probability that the mean age of the individual sampled is within 2 years of the mean age for all individuals in the city. We want our sample mean to be close to the population mean, so this is a very good question to wonder about. Hint. Find the sampling distribution of the sample mean and use the central limit theorem. You don't have to know the population mean to answer this, but if it makes it easier, use the values such as mu equals 25. Okay, we'll use mu equals 25. Let me show you what I'm writing down so far. I didn't really write down much. I just wrote down n is 100 and that the standard deviation is 16. They said we don't really need the mean, but I'm gonna use it because they gave it to me. They said you can use the mean age as 25 for the population. Okay, so I got these three numbers, and what they want you to find is that the probability that our x comes out to be, hold on a second. Um, what was the question? Oh, here it is. Find the probability that the mean age of the individual sampled is within 2 years of the mean age. Within 2 years of the mean age. So, you know what? We have to be careful. Because when they say within 2 years of the mean age, and if you're thinking that the mean age is 25, we're thinking this person can be as old as what, 27? And I got that 27 by adding 2 to 25. But what's the youngest that we're gonna have? 25 minus 2. So this person, or it's gonna be in between these two numbers. But notice I just used that 2. I subtracted this number is, I just want to make sure that you know where all these numbers are coming from. So that's the probability that we want to find. Because they said within 2 years of the mean age. And if they just tell us to use, hey, why don't you use 25 for the mean age? I want to know the probability that the sample mean will be between 23 and 27. Now, we're talking about sampling distribution of sample mean. So we're not going to use these two numbers. We're going to use, we're going to have to first find the sampling distribution of sample mean, which is the same thing as the population mean. So I'm just going to go ahead and use 25. But what about the standard deviation of sample mean? We call this standard error, right? Now, the formula, you need to know that there is a formula so that you can go and look it up. And we'll go and show you where you can find this formula. This is 7.2. And I know you got your exam coming up, and gotta tell you, these exams are gonna be all open note. So and everything you need is already posted on Canvas for you. So just gotta go and search for it. So what I'm looking for is the sampling distribution standard deviation, and it's right here. The standard error formula is the population standard deviation divided by square root of n. So let me go back and write that down. Where am I? Got all these things opened right here. Okay, so I'm back to my problem, and then I'm gonna write down my formula. Standard deviation divided by square root of n. They gave us that the standard deviation for this population is 16, and that the sample size is what, 100. So I'm doing this. If I simplify this, I will get 16 divided by 10, and I can use 1.6 as my standard deviation. I got so many numbers floating around, but all I really need is these three numbers, or this number and that number for the mean and the standard deviation, okay? And I will use my Statcrunch calculator to find the probability that is going to be in between 23 and 27. So make sure that you have these three things written down. Let's go to Statcrunch together. Where is my Statcrunch? I better open it. Go to MyLab and Mastering. And I remove the time limit on your exam too, so you can take as long as 24 hours, well, even longer if you want. But you don't want to be taking this for more than 5 hours or anything like that. But where am I going? I'm going to Statcrunch. So don't feel rushed when you're taking your exam too. You have time. If you need to take a break in between, that's okay too. But I'm gonna open up the Statcrunch so that I can enter my numbers in there. Now the thing is though, can we assume normal? How can we assume normal distribution is okay for us to use? Because that's another topic. Remember the thing called central limit theorem? We don't know anything about the population distribution being a bell shape, but what we also have is if the sample size is greater than or equal to 30, then we can use normal distribution for sample mean distribution. So with our sample size being 100, we are safe to assume normal. So go to Stat, Calculator, and go to, where are you? Normal. And then let's type in between. Mean is 25, standard deviation is 1.6, and I want the probability that x is in between 23 and 27. Let me zoom in so that you guys can see what I'm typing. Mean is 25, same as the population mean. Standard deviation, I had to calculate it using the standard error formula, but that came out to be 1.6. And we want within 2 years of the mean age, so I used 23 to the left and 27 to the right bound and compute it. The answer is 0.7887. I'm going to go ahead and just type this in my link right here. They want you to round to 3 decimal places. So I'll round this up to 0.789. Let's check answer. Fantastic. Awesome. All right, let's do the part B. Would the probability be larger or smaller if sigma is 30? Ooh, it's a good question. Now, you can actually find the probability, but I want you to remember something that we talked about. Now, we're making the standard deviation of the population bigger, right? You know what? Let's actually do this one more time. Let's actually find it. Why not? It's a good practice. So on my notepad, I'm gonna go ahead and change the standard deviation. Okay. Flip the page. N is still N is still 100. N is 100, and mean is equal to still. Let's just keep it as 25. But they are saying, what if the standard deviation is 30 this time instead of what they had earlier, 16? Would the same probability be greater or smaller? That's what they're wondering. So I'm going to do the same exact thing. I'm going to find the probability that x is going to be in between 23 and 27. But our mean of the distribution, while that one stays the same as 25, our standard deviation for the sampling distribution of sample mean will change. Same formula, but on the numerator, instead of 16, we're going to use 30. 30 divided by square root of 100. So if you do that, you'll get 30 divided by 10. So standard deviation is 3. Now notice the old one, the part A, the old standard deviation was 1.6. This time, the standard deviation got bigger. That means this will be more spread apart. Bigger standard deviation. But let's find it. It's a good practice to use that normal distribution calculator on Statcrunch. Hello, Statcrunch right here. So mean is 25. That's still the same. But I'm changing the standard deviation to what? 3. And then keep the same 23 to 27. If I compute it, I got the probability to be 0.495. 0.495. And this is less than what we had before, right? Because before we had 0.789. If standard deviation of population were larger, the standard deviation of the population would be bigger, will be larger. We saw that changed from 1.6 to 3. So the probability would be larger. And I actually found them and then I compared it instead of just kind of going with the concept, and that's completely okay. So let's go ahead and check answer. Oh no, what happened? I better double check. Oh, I know exactly what I did. I know exactly what I did wrong. Guys, the probability came out to be lower. The probability was 0.495 and the first one was 0.789. So I should say the second part came out smaller. So that was my mistake. So, and then let me check answer. Yay! So that's it. So that's, it took me some time, about like 13 minutes to do this problem, but that was a good problem. Hope you get to try a similar problem on it, and let me know if you have any other questions, okay?